Welcome back. This is Marco Ortisi, and it is officially the first time I speak in English on this channel. Today, I want to show you what are the security implications when the least privilege principle is overlooked by vendors. I discussed a bit about the least privilege principle in my previous video. It was in Italian. And just to recap, the least privilege principle was conceived more than 50 years ago, around 1973, 1974, and simply states that your applications, programs, users, processes, etc. should be assigned the least amount of privileges strictly necessary to perform the task they are called to fulfill, to accomplish. It is a common sense principle, but apparently not respected and systematically violated by vendors nowadays, and this has huge impacts in terms of security, especially in the edge device areas, so such as SSL, VPN, load balancer, and network gateway, firewall, etc. After I recorded that video, I started to think what example I could bring you practically, and suddenly I reminded about a vulnerability, actually a trick that I discovered 5 years ago on a product called Cisco ESA, Cisco Email Security Appliance, that now has been rebranded to Cisco Secure Email Gateway. Well, I believe this product is a pretty good example of bad practice when it comes to respecting the least privilege principle. And I thought, okay, there is no way the same trick I abused 5-6 years ago still works nowadays in latest version of Cisco ESA. So what I did was downloading the virtual machine of the product. I installed it, and guess what? It was vulnerable. So it is vulnerable today as well. And I will show you how to abuse this trick in order to escalate privileges. Before doing that, I want to connect to the host. Yes, I have installed it, configured this IP. So we are connected via SSH. There are a couple of things we should say before moving forward. First of all, I'm using the admin user and I'm connecting via SSH, as you can see, but the default behavior is to get a restricted shell. So I had basically to jailbreak the virtual image, and this is out of scope in order, to get an interactive shell access. Second thing, the admin user is defined at the level of the operating system as an unprivileged user, so a user with not privileges. So it is not inside sudoers. You cannot use to escalate to root like in a standard fashion, so to say. Another thing, you can see here the version of Cisco ESA, and this is latest version, as I was mentioning, and async.os in nothing more than under the hood, this is FreeBSD, basically a FreeBSD kernel. Cisco has decided to rename as async.os. With that said, the first thing I'm going to show you is the list of processes which are opening TCP ports. And you can see that aside from PostgreSQL and Nginx, everything else is running as root. But with the memorable exception that while Nginx is an open source product, and basically this is a standard configuration, so by default it spawns a parent process as root, and then all the child processes, the children are basically unprivileged, like you can see here. The other processes instead are custom Cisco processes, and they are running as root deliberately. So this is a good indication when I started my analysis. The least privilege principle is not very well implemented. So there is no real privilege separation. And I want to show you a typical scenario that an attacker could find in this situation. So let's assume we are the attacker operating on the internet, and this attacker basically wants to exploit this Cisco ESA box. And let's assume is interacting with the Nginx service, and he finds a way to exploit a vulnerability in there. So let's say an RC vulnerability. So now we know that the children of Nginx are running as nobody user. So what does it mean? When the attacker will execute remote command, these commands will be executed as nobody user. This is still cool. You are inside the system, but of course, the attacker wants to escalate their privileges to root in order to get full control of the box. And this is the reasoning that I did at the beginning. So inside the folder of the admin user, I have basically created my exploit. We are not going very deep into the technical detail of the exploit, but I want to show you, the process, the procedure that I went through in order to discover this vulnerability. First of all, even with PS, with the process list, you can see that almost everything is running as root. In particular, after several analyses, my eyes were captured by this command D daemon. So the command D daemon is very interesting because, as you can see, it creates a Unix domain socket and listen on that socket where commands are basically received and processed. We have a situation like this basically. So inside the Cisco ESA box, there is this command D process. So all this can be defined as Cisco ESA. Just the rectangles are the single processes, representation of the single processes running inside the product. And so we have command D in here. And command D is exposing a Unix domain socket, command D.sock, where other processes can connect to, sending commands which are processed by command D and send back to the caller this way. Now, the fact is that the commands sent to command D are basically serialized Python objects. And this is very, very dangerous. And indeed, if we look at the exploit, we can see that the exploit establishes a connection to the local socket path. So it creates socket and connects to the Unix domain socket of command D. Then basically it starts to set up some parameters like source, destination, TTL, timeout, tag. and send all these parameters with send message. Here I've used the internal APIs implemented already with Cisco ESA. We are sending like a message hello command, and the interesting thing is that message hello command basically can come with a payload, which is this message here. And what the payload is, actually, it is a serialized object. We are wrapping around our malicious Python code to the test object, and then basically message will contain a serialized copy of this test object. What happens is that some process will send message hello to command D with the malicious serialized payload, and command D blindly will deserialize it. And when the deserialization is triggered, this code specified here is executed. So what we are going to do in this case is just copy bin shell into the temporary folder, giving the name backdoor. Then we are enabling the suite bit on it, and we run it. And at that point, from admin or from any other user, we should become, like nobody, for example, we should become root user. So let's see if this is actually true. So we are right now admin user. I touched file AAA, you can see here. So now I run sparka.python, the name I gave to my exploit. And we are root. So the ID command doesn't work here, but if we touch a file, you can see SSSS has been created by root. And then we can do whatever we like we can show the master password with hashes, we can modify it, we can go inside the root, we can write in there, whatever. So basically we are the master of the system with full privileges. So please do not overlook the least privilege principle. Yeah, it is a common sense principle, and it should have been well established principle actually, but it doesn't look like that, and the disaster is always behind the corner. This is also the reason why I tend to say that the least privilege principle should be one of the first thing you have to look at if you are deciding to buy a new device and before attaching it to your network. So yeah, have a nice day, guys. Bye.